titration. Okay, clear. So first of all, we understand what is the meaning of precipitation titration here. So there will be two compounds. Okay, for example, I'm taking in a general form. So the general form I'm taking in the form of A, B, C, D. For example, I'm having a reaction which is A, B, it is combining with the C, D, and we are getting the compound which is, okay, let me consider the charge as well. So I'm considering A positive, B negative, C positive and D negative. So after combining, the formation of the compound will look like, which is your A positive and your D negative plus C positive and your B negative. So these are my compounds here. Okay, since we have to consider the precipitation part here, so for the precipitation here we will be considering that AD is my PPT. So since it is a PPT, so it will settle down into the solution. Okay, so now we have to draw some graphs based on the same thing. So before moving ahead, we are considering few extra points here. So number first extra point is there, which is our, let's consider that initially I was having 5 mole of AB and 1 mole. Okay, slowly I have been adding this amount of C, D inside the solution of the AB. Okay, so what will happen after the after combining or after reaction, we will be having the formation of 1 mole of the compound AD and as well as 1 mole of the compound of C positive, B negative. Since it is your PPT, so we will be considering it will be settled down, so we will not count in the part of titration. Okay, now since this is a part of CD, so CD will consume at the first place, it will be our LR, limiting reagent, and the remaining body or remaining value will become our 4 mole. Clear? Very good. Initially if we see here, okay, like before the reaction, so you can see easily in the part of A positive, B negative, if I dissociate these ions, so you will say A positive ions were 5 mole initially, and similarly B negative ions were also found 5 mole initially. Clear? But if we check about after the reaction, okay, after reaction, so we will be having, for example, 4 mole. So these are our 4 mole here. So it means A positive will be equal to our 4 mole and your B negative will become also equal to your 4 mole. At the same time, if we look into the part of the product side, C positive, B negative here, so here you can see that is we are having, after dissociating, if we dissociate the ions, so we can say, sir, 1 mole we will be having C positive ions and 1 mole we will be having B negative ions. Okay, since all the things are present in the solution, so easily we can say B is having 4 mole here and B is having 1 mole here. So if you check in both the areas, so the total number of moles for the B will be equal to your 5 mole. Okay, B negative. But here 1 mole of A positive, okay, 1 mole of A positive has been replaced by the C positive 1 mole. Okay, so here we can say that C positive replaced your A positive ion. Okay, so far I think everything is clear to you. Okay, so initially we can say initially and finally, initially and your finally compound जो है, like initially and finally, B negative ions will be equal to each other. Okay, so B negative will be 5 mole initially and as well as finally 5 mole, but A positive has changed. Clear? So far everything is clear, it seems. Now we will move on to the part of the next part. So here we have to draw the graph. Okay, so let me take one more page here. So we are having 3 graphical representation here. So first graphical representation we will consider, that is if the C positive ions have less mobility. Okay, they are having less mobility than your A positive. So first graphical representation we will be having based on this one. Clear? Okay, so since we have considered C positive ions mobility are less, So here I will write like this, it is less than A positive ions mobility. So based on the same thing, okay, for your better convenience, I'm again writing the reaction. So we had AB plus CD, and the formation of the compound was found, which is A and D and plus C and B. So that was our PPT here. Clear? Okay. So AB was found 4 mole after the reaction, and it had become 0 mole. It is your PPT part, and here we are having 1 mole, this one also. Now consider, for example, we are having a solution here again, and in the solution continuously you have been adding the value of the CD in the part. So what will happen after some time? Okay, so CD is actually here. In the previous slide we had understood here very well that C positive has taken the place of A positive. Okay, so according to the first state, we had considered that if the mobility of C positive ions are less, so here, since according to the part we can say directly, since the mobility of C positive ions are less, so initially, okay, initially the conductivity of the cell, okay, or the conductivity of the solution, here we can say the conductivity of solution decrease. Why it will decrease? Because all the positions had been taken place by your C positive, and if C is your less negative, less mobile here, then it will be reducing the conductivity. But up to when it will be reducing? So you will say, sir, till the equivalence point, okay, equivalence point reached. It will be decreasing the conductivity till the equivalence point is reached there. And based on the same data, if I try to draw the diagram here or the graphical representation, so I can say directly, if it is my conductance part and it is my volume added for the part, so here, so initially what will happen, the conductivity will start reducing like this. Okay, so let me mention the other things on the graph. So left hand side I'm taking as my conductance part, and here it is my volume, and especially this volume I'll be considering the volume you have been adding for CD. Okay, so because of that, here we can say this graphical representation will be reducing up to or until the equivalence point does not reach. So it is my equivalence point. But what happens after reaching the equivalence point? Okay, so if the equivalent point has reached there, now come back here again, if the equivalent point has reached there, so now in the container, okay, the complete AB will be completely consumed, CD will be completely consumed, okay, up to, for example, if I add 4 mole here more, then it will be completely consumed. So after the complete consumption of the AB, if you will be continuously adding CD here again, so since AB had completely destroyed or AD had completely gone from the solution, so this CD will again start increasing the conductivity of the solution. Okay, so here we will say that graphical representation for the case will be like this. So here, okay, here the graphical representation will be based on, since in the solution you were having, what was the solution content here? CB initially. So based on the same thing, here we can write directly, since we were having CB, let me draw it properly. So here I will draw my graph like this. So wait, let me write properly here. Yeah, so this graphical representation will be for your CD, okay, and plus your AB initially. But now AB had been completely consumed, so you will say CD. Okay, so now AB had completely consumed, so AB had completely gone from the solution. So CD, sorry, instead of writing CD, I had to write CB. Yeah, CB plus AB. Okay, so CB plus AB will be in the initial case, but after the after completely consume of the AB, so we will be having the graphical representation for CD and your, that is CD and your what was that, CD and CB. Okay, CD and CB. Okay, So this will be the graphical representation for this equivalence.